And so I'm going to talk today about Polymer, what it is, what web components are, and kind of the new world of web development that this allows for that you've never been able to do before on the web. So a little bit on the agenda. I'll start with web components, go over what the specs are, how they work, then go into Polymer, how Polymer ties these together into a coherent whole as a library. And then I'll go into kind of the things you can build with Polymer and what web development looks like in the web components world. But first, to set kind of the stage and the context, what problems are we solving? What are we trying to do with web components? And as many and all of us probably know, expectations of web developers are higher now than ever. They're extraordinarily high. We're competing with the native platform. So we've got to build web applications, web experiences that are 60 frames per second, that are silky smooth to the touch, that drag under the finger, that work across a whole variety of different screens, a whole variety of different browsers, now a whole variety of different devices, and even like wearable devices. And this is a very, very high bar. And the tools we're given as web developers are not meeting that bar. So the tools we get, the primitives that we get when we're developing for the web are great for document markup, which is what they were originally intended for. You get headers and lists and paragraphs. And they're not so great for building today's kind of web UIs. So I'll give an example. One very common UI paradigm nowadays is tabs. It's very simple. It's kind of across all kinds of different applications. You might need some tabs. Building UI tabs should be easy. It's so common, it should be easy. But it's not. We have a million different ways to build UI tabs on the web today. Some ways you're kind of overloading the existing kind of HTML tags. So you've got lists as your tab items and then divs separating content. And then you call this kind of magic JavaScript incantation that knows how to do it and arrange it and put them in the right places. Other ways try to go more towards script. So you're defining all of your content and data actually in JavaScript as a JSON object or whatever it might be. And then somehow it gets arranged and stamped into DOM, and then it shows up on the screen. And then some do a mix. So some are trying to do everything in JavaScript, but then you kind of inject HTML inside of there, and then maybe you have some more JavaScript syntax inside of your HTML, and it becomes these Russian nesting dolls of script and tags and everything to somehow get these UI tabs to render. So I looked over to do MVC this morning and kind of pulled out all the different JavaScript frameworks that try in some way or another to give you the handles to be able to do model view controller. To do MVC is a great kind of showcase of all the different JavaScript frameworks. And I don't mean to disparage this by putting a long list at all. This is awesome. This is something you could only get on the web platform. The kind of variety and the different ways to approach the problem are a showcase and testament of how powerful the web platform is and how many different ways you can create to solve problems. But it is an indication that there is some deeper issue with the web platform, something that it's not quite capturing or that you wish you could do that could make all of these framework developers' lives way easier and all of us web developers' lives way easier. It shouldn't have to be so hard. It shouldn't have to be this hard to create something as simple as UI tabs. And I'll give an example of why it shouldn't have to be so hard. And the primitives are actually already there. The web does a lot of awesome things for us natively on the platform. So as a kind of use case in a case study, I'll look at the select element, which is one of my favorite elements. If I could list my favorite HTML element, select would be way up there. It's a really neat element. So first, it's really simple. You can put a select tag on your page, and you get the select element. And this just works. It works across all the browsers. It gives you kind of a native feeling UI with this drop-down list. Of course, it's going to be empty. But it's super simple. And the best kind of example of how simple the web platform is in general is it's the only mainstream platform where hello world is just hello world. If you type hello world on a page and load it in your web browser, you'll see hello world. Even though it might not be valid, it'll still work. And select is just that same simplicity. You get the select tag, you put it on there, it renders. It's composable. So you can put children inside of your select tag. Your select tag takes options. You can put options inside of there, and the select tag just knows how to lay it out. So magically, by putting these simple options inside of my select tag gives me this drop-down menu. I can click it. I can select which one I want. It just works. Across all the browsers, it just works. It's declarative. So the API for the select tag is declarative. I can read it. I know exactly what it's doing. I can put disabled or selected attributes. And again, the select tag will render the right way. It'll gray out any disabled attributes. It'll have selected with the little tick mark next to selected. Really awesome. I can read it. I don't have to write any script. It's just declarative right there on my file. It's flexible, so it can take more than one type of children. So you can put op groups inside of your select tags, and that'll group it correctly, giving you different headers that aren't selectable. You can do select multiple, which will give you a totally different layout. It'll give you you can select more than one thing. It's no longer a drop-down menu. It's just a box, and you can select them two or three at once. And again, I didn't have to write any script to do this. It's purely declarative. I set these as attributes on my tags. It's forgiving. I can make mistakes, and it's not going to just kind of crap out, and my entire page is not going to render. If I put a p tag inside of my select, it just ignores it, just drops it on the ground, keeps on going, doesn't crash my web page. It's accessible, so I get a lot of accessibility baked into this tag by default, and what isn't baked in, I can label correctly to get it right. So accessibility is a great part of the web platform. It's really powerful. I can set a label for my select tag. It'll link it up. Screen readers will know what to do. I can also get all my keyboard input. I can tab through the select tag and all the options and select the right thing. And finally, what I can't do declaratively, it's programmable. So I can script it. I can set a selected index. I can read a selected index. I can add event listeners to it to get notified when things change. So everything that I can't do declaratively, I can do in script and programmable with this object that I get from the select tag. So this is really cool. It's a pretty neat behavior that I get where I can build it all declaratively without having to write an ounce of script. And when I do need script, the API is right there. It's really simple, straightforward. And I get all this, and it's encapsulated. So I can drop it on my page in a form or as a navigation menu, and I can use select tag however I want. It's not going to screw up the rest of my page. It's just going to work. So my thought is then, I want more elements like this. This is great. I want to have a UI tabs element. How great would that be? The downside is, with HTML5 we got a few more elements, which was awesome. In the web platform in general, it's really hard to put things new native in the platform. As we might know, there's working groups, and you've got to go through these things. Then you've got to get browser vendors to implement it, and then they've got to ship it, and then developers have to start using it. And so end to end, to create a new element like this would take years before you actually get it in the platform. So I think a better statement is I want to build elements like this. I want to be able to create an element that has all this great native value that the select tag has, but I want to be able to call it whatever I want, and I want to give it whatever behavior I want. I don't want to have to wait for it to be actually implemented natively in the browser. So this was the dream of web components. What would it take to create my element? What would it take to create kind of my own element with all the properties that the native select tag has? First, I'd have to be able to give it a prototype. So I want to give it a prototype in JavaScript. I want to tell it what its methods are going to be, and give it some basic layout, and let the page know that it exists so that I can actually put this tag on my page. I want to be able to define its internal layout in HTML. So the select tag has internal layout. I don't want to have to write some kind of domain-specific language. I don't have to write C++ to try to get it to render correctly. I want to just be able to define however my tag lays out its children in HTML and JavaScript. I want it to manage and abstract away its children in internal styles. So if I put CSS in there to style its internal behavior, I don't want that to affect the rest of the page. I want it to be kept internally. I want to be able to understand its children, lay them out as it needs to, but I should be able to just drop my element in a page, and it shouldn't mess anything else up. And I want to let it declare and handle its dependencies. So if it depends on other elements that I might have created also, I want it to manage that. I don't want to have to tell it, okay, here's your also child element that you might need. I want it to manage its dependencies on its own. So these 4 characteristics is what inspired web components. So what web components are is a new set of specs in the W3C that basically gives developers the primitives that they need to create exactly like native elements themselves, their own custom elements with all of these behaviors, and the web platform to actually understand these elements, and the browsers to render them just like you would a select. So it's 4 different specs, and I'll go through each of the specs independently and what they are. So the first is custom elements, and custom elements is exactly what it sounds like. It lets you define new HTML and DOM elements. So we might recognize this. This is kind of the applications we get today. We call this div soup. It's just a bunch of soup of divs. And divs are great because they're really expressive, but I have no idea what a div is. It's just what I use to create my web apps. It's not meaningful at all. It's not semantic. It's really hard to understand what any of this is if you wanted to change it. Certainly, if I'm opening up Inspector and I don't know what to touch. I have to find the right place in my page. And this is a real application. This is Gmail, and I'm from Google. We built this. This is what we built. And I will give, if any are Gwt people in the audience, I will give Gwt a break. This is kind of generated from Gwt, and Gwt is really interested in web components as a framework, so that this will hopefully change. But this is today. And so what custom elements are is it lets us define our own custom elements. So instead of having to use divs everywhere, I can define my element, what I want, whether it's an email line or whether it's a paper tab. I can define that. I can give it a prototype, and then I can register it, and I can use it on the page wherever I need. So it's meaningful, it's declarative, it gives us a common way of extending elements as well. So if I don't want to create my new element from scratch, but I want to extend kind of a native input, for example, I can then extend it, inherit from it, get all the properties of input, but then add my own properties on top of it. And custom elements are scriptable just in the same way any native element is. And for all intents and purposes, the browser understands your custom element as a native element. So you can query select for it, it just works. And then you can set event listeners onto it, and it also just works. So this is purely a native element once you've registered it with the document. The second spec is templates. So again, native client-side templating. This is probably well understood as a problem that modern UI frameworks try to solve in a million different ways. Some try to put kind of HTML markup that they don't want rendered inside of a script tag, which is, it works sometimes, but there's side effects and it overloads what a script tag means. Some try to put it as like a display none, and that also might have side effects. It kind of overloads what display none means. Some put it in JavaScript itself as a string, which is fine, but then you lose a lot of the properties that DOM gives you. So templates are just native client-side templating. So it's the addition of the template tag, which basically says all this markup in here, I don't want it rendered. I want it to be parsed, though. It's going to be inert. You're not going to execute any script that's inside of this. It's going to be a document fragment, so it's going to be outside of the main document, and then I can stamp it in whenever I want. So it's a true native client-side template, which works exactly the way you'd expect, and it's great for building web applications and with templates. The third spec in web components is Shadow DOM. Which I think is the most subtle and probably the most complex, but also incredibly important and the most interesting spec. So Shadow DOM gives you the scoping and composition primitives that we would expect with native HTML elements. And the interesting thing about Shadow DOM is Shadow DOM already exists. Shadow DOM is this great secret that browser vendors have been hiding from all of us web developers, and keeping it a secret, using it for their own elements, but not letting us have the power that is Shadow DOM. So if you create an HTML5 video tag right now in Chrome, and open up DevTools, you'll see that it's actually Shadow DOM. So you can turn on in settings user agent shadow root, and you can dig into what makes up the video tag. And if you look at the video element, it's got this UI. It's got a play button, it's got a scrobbler, it's got a mute button. That's not magic. That's not some magic native C++ code that gives us that. That's HTML right inside of here. It's a bunch of divs and inputs and styles and things, which is really neat. I mean, I've used HTML to structure my internals of HTML, but it's this dirty secret that, or actually brilliant secret that I can't use as a web developer. So Shadow DOM basically exposes this ability to create a shadow root in any element to the end client web developer. So what this gives us is the two main properties I said, composition and encapsulation. So I mentioned with my select tag that this is composable. I can put children inside of it. The children can be simple, and the element itself knows how to lay it out with its own UI. So that's the first piece of Shadow DOM, which is projection. So if I wanted to create my select, I might write something like content, which is the element inside of Shadow DOM that says this is where I'm going to project all my children through. And then I can actually select for certain tags or do some basic CSS selectors to pick out which children I want to insert right at this point. So I might put something like content select equals option, which would grab all my option tags, and then anything that the user puts inside as options in their select will then be projected through. And the other side of Shadow DOM is encapsulation. So I want tree encapsulation. So I don't want to have I don't want these elements that are inside of my Shadow DOM to appear to the outside. I don't want them to get selected and moved around. And I also don't want my style to leak out. So if I want to, again, build my select, and this is a very contrived example, but if I wanted to build my select element, I might set some style inside of it. So content saying all of my projected children that are hovering, I want the background color to be blue. So that would give me kind of this behavior that you'd get inside of the native select element. And it's an abstraction that doesn't pull away from the page. So it's not going to affect any other elements externally outside of my select element. It's totally encapsulated. So those are two kind of great properties that Shadow DOM gives me, which you can see you really, really need if you want to create anything like a native HTML element. And the last spec of web components is relatively straightforward. It's HTML imports. And this is basically letting me load web components. It's dependency management for the web. So an example, if you wanted to use Twitter Bootstrap today, you've got all these different files, all these different things you have to put in your head. Some is CSS, some is JavaScript. You link them and pull them into the page different ways. But you have to remember all these things if you really want to use the power of Bootstrap. What if you could just have this one line that's link rel equals import, and then define all its dependencies inside of one HTML file? So that's what HTML imports gives us. It gives us a way of loading HTML. We don't really have that today. And then it gives us a way of defining dependencies and then abstracting that away so that this understands all of its dependencies, bootstrap.html, and it can load those in itself. So that's web components. We have custom elements, creating new HTML elements and extending existing ones, templates, which is native templating, Shadow DOM, which gives us composition scoping, and HTML imports, so I can do dependencies on the web. This kind of sad part right now is this is native browser support. So a lot of browsers have implemented templates. Fewer have implemented the other three specs, although there's positive signals from Firefox and IE on these. And so this is coming, but I'll get to this a little bit later. But it begs the question, how do I tie all these together? I've got these four very powerful primitives, which you might see starting to evolve a kind of way of building elements, but right now they seem kind of disparate and pulled apart. So this is where Polymer comes into play. And so the Polymer library itself, before defining what it is, I'll define what it isn't. So when people talk about Polymer, you might see, if you were to Google this today, there is a lot of confusion out there. This is a very, very new library. And so there's a little bit of confusion about what Polymer itself is and what it isn't. So there are three typical layers that come along when we talk about Polymer. There's the polyfills layer, the Polymer library itself, and then there are elements built with Polymer. And so I want to be really explicit up front that this middle thing, the library itself, is what I'm talking about when I talk about Polymer. Elements built with Polymer are totally, they're their own world. They're whatever you want. And the polyfills themselves also are what allow Polymer to function, but it's not Polymer. When I talk about Polymer, I mean just the very thin library on top of web components. So I mentioned the polyfills, and I mentioned browser support didn't look too great. I showed this slide before. This is native web components implementations on browsers as of this moment. With polyfills, you get support across browser. So you get support for all evergreen browsers and also IE 10 and up, Safari 7 and up, and then across mobile browsers as well. So what the polyfills are basically emulation of the web components APIs, but in JavaScript. So we fake it. The Polymer team initially built these polyfills to help Polymer work, but they're used across any web components library today. And we actually we moved them away from the Polymer name, and so they're owned by webcomponents.org, which is kind of the broader organization that all web components libraries and browser vendors are a part of. So polyfills are no longer part of Polymer. They are just web component polyfills. So you can use web components natively using the polyfills, never have to have Polymer enter your world at all. And so this is great. So this lets it work today. So Polymer.js, this is the library. This is Polymer core. This is what I'm talking about when I'm talking about Polymer. So what is Polymer.js? So Polymer itself is and is nothing more than an opinionated library that sugars web components to make it easy to build encapsulated reusable elements. So the key part of this sentence is opinionated. So when we set out to build Polymer, the web component specs were evolving as Polymer library was evolving. There was kind of this back and forth between the spec team and Polymer, and saying, this would work for web developers, this wouldn't work for web developers. And so Polymer itself tried to create an opinion around how can we tie together these web component specs to make it as easy as possible to build your own element. So Polymer's opinion, I divide it into three kind of categories. There are three main philosophical tenets that Polymer is based on. The first is more sugar, less pain. So it should be easy to do easy things. This is surprisingly more debatable, I think, than I expected when I usually put this up there. But it should be easy at the end of the day to do easy things. You don't want to spend your time and your brain power doing boilerplate. You want it to be easy to do easy things, then you want to have the power to do more complicated things in a way that fits best. Second is interoperate and don't dictate. So Polymer is purposefully a bottom-up library, not a top-down framework, and I'll get more into that. And the final is declarative first. So what makes HTML great is its declarativeness. You can type an element on a page and it'll just work. And so anything built with Polymer should work the same way. So I'll go through these three opinion pieces one at a time and show how Polymer expresses that, how it manifests in the Polymer library. So the first is more sugar and less pain. And so I'll go through the web component specs that I mentioned earlier and show kind of how Polymer sugars on top of these web component specs. And the first web component spec was custom elements. So if you wanted to create a custom element yourself, if you want to do it in vanilla JavaScript, vanilla web components, you can do it. You can say document.register element, give it the name of your element, add a prototype. So in this case, it's kind of the basic HTML element prototype. And then you can use it on your page. With Polymer, we say this is kind of, it's a little difficult to do that. It's not straightforward. You have to write a script tag to be able to register an element. So we created the helper Polymer element. So I say Polymer element name equals paper tabs, and then this will register it for me. So this kind of sugars over lightly, very lightly sugars over the register element and giving it a prototype. And this, again, in both cases, I can then use paper tabs just on my page as if it is a native HTML element. So the second was templates. The second web component spec was templates. So if you wanted to use a vanilla template, of course, you can just do that. You can create a template tag on your page. but everything in there is going to be totally inert. It's not going to render. It's going to be parsed. It won't render. So if you want to actually stamp it out, you have to select for it in JavaScript and then clone it and stamp it out onto your actual DOM. In Polymer, we say everything that you want to, every markup, all the markup you want to put inside of your element. So everything you want to make your element work should be inside of a template. Because obviously you want to use an element more than once, we would hope. That's the kind of whole reason why you're creating elements. So everything that inside of a Polymer element is inside of a template, so it's naturally parsed but not rendered, and you get this property of being able to stamp it out. So we also extended the template element to make it kind of more useful than just a basic template element. And so we have this template repeat function. So if I want to have repeated items in a list, for example, I can use template repeat, iterate for me, and stamp out these nodes. So this is great. It makes it really easy to build Polymer elements that have some level of abstraction inside of how its DOM lays out. The third spec was shadow DOM. So I mentioned it's subtle, it's complex. You can do it in vanilla web components. So I can say element.create shadow root to any element on my page, and then stick some inner HTML inside of it, and that will be hidden away from the main document. It'll get all those great encapsulation properties. But again, it's kind of hard to think of a reason in JavaScript I might want to do this. And if I do want to do it, it's a lot of boilerplate, and it's kind of messy. It's hard to read. So again, in Polymer, we said everything inside your template, everything that you define inside of your element that isn't projected, so doesn't come through a content tag, it's all going to be in your shadow DOM. So if I'm trying to build that HTML5 video tag, everything that I use to mark it up, the play button, the scrobbler, that's all going to be automatically put inside of a shadow root. So you'll notice I didn't have to call any script here. Polymer just handles this all for me. And it kind of is pretty straightforward why we would want to do this. You can put styles inside of your element that style everything in your element, and it automatically won't leak out. It's a great property of elements, and Polymer just assumes you're going to want that. And so in both cases, again, I can use it. I can just use my element on my page, and then I can put children inside of it, and they'll get projected through as long as I have that content tag inside of there. And then the last web component spec, we don't actually sugar HTML imports much at all. We just expect that each element will be in its own file. So you put each element in its own file that you create with Polymer, and then you import its dependencies at the top of the file. So in this case, I have my Polymer element as my profile card, and it depends on Polymer, obviously. It will manage that dependency on its own. So if you want to then just use it on the page, all you need to do is say link rel equals import the specific element that I want, and you can immediately use it. It'll manage its dependencies for you. You don't have to have that big boilerplate bootstrap style block of imports just to use a single element. So that was the first piece of Polymer's opinion, more sugar, less pain. The second piece, which I think is really important to understanding Polymer and what Polymer's goals are and what Polymer's goals are not, is the interoperate and don't dictate piece. So bottom up, not top down. So this is a great quote that was on Stack Overflow for the answer to framework versus toolkit versus library, and I find Stack Overflow tends to be a source of great quotes as well as horrible quotes, but this is a great one. So when you call a library, you are in control, but with the framework, the control is inverted, the framework calls you. So if you're using a library, you're using it like a tool. It's like a hammer. When you need to strike a nail, you are using your hammer to strike the nail, and you can use it or not use it as you choose. A framework, you have to buy into the whole world. So it's like having an entire mechanical bodysuit to hammer a nail, and hopefully it has a hammer on it, but you're stuck inside this bodysuit regardless of how you want to use it. Or even if you just want to hammer a nail, you're stuck inside the bodysuit. So Polymer is very specifically, and every time that we refer to Polymer, we try to refer to it specifically as a library. It is a tool for you to use. It is not defining the world. So you don't have to buy into Polymer as a whole. If you want to use Polymer, you can use individual elements built with Polymer and never have to know that you even are using Polymer at all. So you'll notice that in the previous example, the element itself imported Polymer. I, as a user of paper card, never have to know that it's using Polymer. To my opinion, it is just an element that I imported. And so that's great. It's a great property of Polymer. It means that it works nicely with everything else. So I'll give an example of that. Let's say we just wanted to build this simple app. So it's a map. It's got a kind of tab, a pet drawer that pulls out, a responsive drawer. And then it might have some routing so that I can kind of hash a URL that goes to a specific place on the map. So how would I build this if I wanted to put this together? I could pick a framework. Frameworks will handle a lot of this for me. There are a lot of great frameworks out there. The framework world is always evolving. There are literally hundreds of frameworks. And it'll give me all these tools for the most part. It'll give me routing. It'll give me a way of rendering componentized elements for the most part. Some even give me a server side like Meteor, which could be really cool if I want it integrated, write JavaScript all the way down. But at the end of the day, I have to buy into the whole framework, which might be great. Your team might buy into the framework, You're committed to it. You know it's going to be maintained. So you can buy into it, and you like its model, and you're happy working with that, and that's awesome. But with Polymer, we say we're not a framework. We're not trying to make you buy into it. At the end of the day, anything you create with Polymer is just an HTML element. You should be able to use it however you want. So on the Polymer team, we like to use Polymer in general. It's got some nice, useful features. So we tend to write entire apps out of Polymer elements. So our top level element, our page might just look like body, my app tag, close body, and then all the logic and all of that is encapsulated inside of the my app element. And then I can use a router that's an element. I can use a sidebar or a drawer panel that's an element, and I can use the map itself as an element. But you could also not do that. If you're writing Meteor and you want your server side to be Meteor and you want your logic on the front end to be Meteor, you can totally do that. You can use whatever you want to structure your logic and structure your data flow. But if you wanted to use a Google Maps element to actually show the map because you didn't have to write all that you needed in JavaScript, you can totally do that. Just use a Google Maps element. Don't even have to know that you're using Polymer. It's just a Google Maps element. And similarly, if you want to mix and match, you can totally do that too. So we have a guy on the team that really likes the backbone router. It's simple, it's straightforward. He writes his apps with a my app tag, and then as a router piece, he just uses raw backbone JavaScript. And then inside of that, he might use a drawer panel, and then he might prefer the Google Maps API. So again, it's totally flexible. It's interoperable. Don't dictate. Anything that might understand a custom element can totally use Polymer elements and not know the difference. Be none the wiser that it's using Polymer under the hood. So this is a really important tenet for us. And we try to build everything we do with this in mind, that we are the platform up. We're not this logical abstraction down. And so we should be interoperable with everything. And in places where it's not interoperable, we're working hard to make sure it is, and we're working with framework authors to make sure that they understand these web components as well. So the last piece of Polymer's opinion, I said more sugar, less pain, interoperate, don't dictate. And the final is declarative first. So declarative is what makes HTML great. I can just write markup, and it just works on my page. And so declarative is kind of best expressed through the components that we have built using Polymer. So I mentioned that there were 3 layers that people often confuse with Polymer: the polyfills, the library itself, and the components. The components are not Polymer, but they are built with Polymer. So the Polymer team has built a bunch of components. And why even bother with components to kind of go back? I showed this slide earlier. This is what you get if you're building web pages out of today's elements. You get elements that are great for document markup, not so great for building apps. What if we could change that? What if we could rewrite HTML for the modern web? What if we could create all new elements that are exactly what we need to build and structure our app in HTML? What if we got animated pages and menu buttons and image carousels? What if we redesigned HTML for the mobile web? So we'd go from this, which is kind of the overloaded div, and it's really hard to read, really hard to maintain, to an app with an icon as an element, and a field as an element, and a drawer panel as an element, and a floating button as an element. This would be a really beautiful way of building web apps. It would be, you can imagine you'd be much more productive, it'd be much more expressive, much more easy to maintain, much easier to onboard people and new developers to work on these things, and much easier to kind of encapsulate work into individual elements, and then have some top level piecing them together to build the app. So we built a whole bunch of these elements to kind of showcase and bootstrap the element ecosystem using Polymer. These are not Polymer itself. If you're using Polymer, you don't even have to know about these elements, but they're there to kind of showcase what you can do and to help you start building apps right away. So we've built 2 sets of elements so far. The first are the core elements. And the vision of the core elements is, what if we just, again, rebuild HTML for the modern web? So the core elements include visual as well as non-visual elements. And visual elements are straightforward: toolbars, header panels, etc. I'll get into some of those. Non-visual is a little more subtle. What if you could represent some of the ideas that we have where the only way we have to use them today is in JavaScript, but it's a relatively simple API that you get with JavaScript? What if we express that as an element? And so I'll get into some of that too, and some of the power that you get there. So to go into some of the visual core elements and how you might use them, core toolbar is kind of our simplest layout element. So it's a basic container. You'd imagine you need toolbars across all kinds of web applications. How you use it is you import it. So you just have an HTML import, link rel equals import, href core toolbar, and then you just use it on your page. So in this case, I wanted to have some text inside of there, so I put it inside of a div. It's inside of my core toolbar. The core toolbar knows how to lay it out. So it's got this nice top height, and it pushes it padding to the left on my first child. Great, straightforward, simple. What if I want to put more inside of there? What if I wanted to put like a hamburger icon? I can do that. So we have another element called core icon button. I can say the icon is a menu, again, totally declarative, and it lays it out right there, puts it to the side, gives the nice spacing. My core toolbar gives the nice spacing for me. Didn't have to write any CSS to achieve this. I just wrote markup and it gave me this. Of course, I can style it if I would like, but the core toolbar itself gave me all this power right away. So that's relatively straightforward. What if I wanted to get a little more complicated with my layout? What if I wanted a header panel? So a header panel is I have something on top and then I have a content underneath. So I've got my toolbar, which I created in the previous slide. I put that as my header, and then as my body, I just kind of have a content block with some sort of elements inside of that. I can put those both inside of a core header panel, and I get this layout. It's pretty nice. It keeps my header at the top, my toolbar, and then I've got content underneath. And what's great is I get this cool scrolling behavior. So if I want the body to scroll underneath of the header and pin the header, it gives me this for free. This is actually really, really hard to do in JavaScript. It would be a lot of code, and it would be ugly and messy. This is all encapsulated inside of the core header panel. So I got this for free without having to write a single line of script, or really any CSS either. I just laid it out, and I got this behavior. What if I wanted to change the behavior slightly? What if I wanted the header to scroll away as I scrolled the page, so I didn't want to pin it like this? That is declarative for core header panel. So I say mode equals scroll, and what that'll give me is the whole thing will scroll, so it won't pin the header. Again, didn't have to write any CSS. I changed it purely declaratively. You know exactly what this does just by reading through it. Really easy to use, and it's all encapsulated inside of core header panel. And if I wanted to get even more complicated, let's say I wanted a responsive drawer panel. So I wanted a drawer that's folded away or expanded on a wide screen, and then a main body, which is my content, and core drawer panel gives me that. So if I need this responsive element, which on mobile it will be responsive and be hidden away and open up with this hamburger menu, and on desktop it's expanded, core drawer panel gives that to me for free. Again, didn't have to write a single media query, didn't have to write any JavaScript, didn't have to write any CSS. It gives me all of this baked directly into the core drawer panel. So again, a really elegant way of writing web apps, just using these encapsulated elements, just like normal HTML elements, writing markup and getting this behavior. So those were the core elements. You notice that they're kind of boring. Their layout and their things like that, poorly styled, kind of purposefully, very simple. I won't say poorly. But so then we thought, what if you wanted to create elements that had an opinion of style? What if you wanted to create elements that had a way of expressing themselves that was consistent and they could work together, so you could build a really high quality web app that's very well tightly designed just out of HTML? So we built the paper elements kind of in addition to the core elements. What the paper elements are is they're based on material design. So material design is this design philosophy that was expressed at Google I/O last year, which is Google's company-wide design philosophy that is also, a recommended way to build apps using this kind of look and feel. So we built the paper elements based on all of the components and all of the animations and all the behaviors that are defined in the material design spec. So for example, we have a paper input, which gives you this nice input behavior where you click on it and the title goes up and it turns blue and you can type and it does validation. Everything in there, all the behavior that animation is showing is all defined declaratively on paper input. I even have a regex to do validation that's defined totally declaratively as an attribute that's validate. Similarly, paper checkbox. This is checkbox for the 21st century. It gives me a nice little animation. It swirls and swoops. That's something I would not want to have to write and copy every single time I wanted to use a checkbox across, and this is material design. We're going to use this across all our different Google apps. I don't want to have to copy the same 6 line, or it's going to be more than that, 40 lines of CSS and potentially JavaScript just to use a checkbox every time. That's going to be really leaky. So we encapsulate it as an element, paper checkbox. You get it, you can import it, you can use it. Similarly, paper ripple. This is this nice little touch ripple animation. So if you want something to ripple out and emanate from the center of your tap, this does that for you. I would never want to code this. I don't even really know where I would start to get this to work, to ripple out to its container. But we built it as an element. So the way paper ripple works today is you put it as a child inside of the container that you want the ripple to work in, and then it'll just work. You'll get this animation. It'll be great. You can trigger it programmatically. Or you can have the tap trigger the ripple. And then also similarly, paper shadow, we have the shadow system defined with web material design, and where all the shadows need to be consistent across all of our apps, because that's part of the brand, is the shadow depth and things like that. I could have that as a CSS file, but then again, I'd have to copy and paste that into every single app I build. With paper shadow, we encapsulate all these different potential levels of shadow as a single element, and similar to the ripple, you put it in a child as a child of the container that you want, and then you get this automatic depth shadow and potentially animated as well. So it'll lift up off the page and then drop back down. So we built all of these paper elements as a whole design philosophy that is specific to material design, but that is no reason why any company anywhere could build a similar set of elements that is specific to whatever design philosophy that company might have. So you imagine there could be an Apple I element set that is all of the kind of Apple type of interfaces and elements, things like that. Your company could build similar for all your UI. Designers love this because they get to design a spec, and then you can build elements that directly reflect that spec. And you don't have to go app to app to app to make sure that everything specifically fits your design philosophy. You can just build your element sets, and any app can use those, and they know right away, immediately, that they're doing the design the right way. So we demo some of these. We put these all together into a demo app. Topeka.polymerproject.org is an example of this, where we showcase all these nice animations and all of these buttons and ripples and transitions. It's a quiz app. It's kind of dumb. We built this for I/O last year, and we built in like a week, of a small team in a week, because we already had all these elements, and we already had all these animations defined as elements also. So this was relatively straightforward to build, and we got all these nice design animation effects. And so this was a great kind of use case of we can build a design philosophy and then build an app out of that design philosophy almost for free. It's just kind of structure at that point. We also have kind of a showcase of all of the paper elements on polymerproject.org, so you can go through and click and play with them, and it's pretty nice. We also have a designer tool that we built. So this was also built for I/O last year originally, where you'd imagine that because Polymer elements are just HTML elements, you should be able to kind of drag and drop them and put them together and compose them visually if they're visual elements. You shouldn't necessarily have to write markup to get this. There should be a way to visually do this. And Designer is a case in point for that. So with Designer, you can get from a palette of potential elements that are already defined and encapsulated. You can drag them out onto a place to build these together. You can compose them together. So I can drag children into other elements and compose them. And because the APIs are all declarative, I can set styles and I can set padding and everything like that. And I can also set behavior directly declaratively as like an inspector panel on it. So again, this is the power of elements. It's the power of declarativeness. And I can compose elements together to create entirely new elements. And what's even nicer is I'm sure we've all worked with WYSIWYG editors before. Oftentimes when you export the code, it's atrocious. It's a bunch of kind of garbled divs and classes that don't mean anything. So it's really useless at the end of the day. You end up can coding almost everything. This spits out exactly the code I would write because it's just elements totally declaratively done, styled in very simple ways. The elements hide away all the messiness, and so the code that this spits out is totally usable. We build elements inside a Designer all the time and then just copy and paste the exact code to use in our app, or to use it to create another element that we then compose again into more complicated apps, and it's turtles all the way down. So the final thing I mentioned was APIs and non-visual elements, and expressing APIs as elements. So this is subtle but also really powerful. So let's say I want to add a marker to a Google map. Relatively straightforward need. I want to get a map marker and add it to Google Map. If I needed to do this just in JavaScript with the Google Maps API, this would be a ton of code. I'd have to put the script on my page to actually find where I wanted the map container to be, and then I'd have to invoke the map, and then I have to center it, and I have to create the marker object, and then I have to give it a location. It's a lot of code, a lot of boilerplate. What if we could just write the Google Map element, which encapsulates all of this API, and when I put it on the page, I just get my Google Map to appear. So we built this, and this is actually really nice to use. So Google Map, you don't want it to just kind of generally render. You want it to usually render at a location. So we turn the API into something that's declarative, set attributes on your Google Map, say give it a latitude and longitude, and it'll center right there. If you want to give it a zoom level, again, totally declarative. It'll zoom in, and this will just work. But I mentioned I wanted to put a map marker inside of my Google Map at a certain location. And again, the great part of HTML is it's composable. So I can put children inside of my Google Map. And that's exactly how Google Map Marker works, is I just put it as a child of the Google Map container I want it to be in. Again, totally declarative. I give it a latitude and a longitude. I give it a title. I set whether it's draggable or not. And I get that marker right there on my Google Map. So a great way, a great example of encapsulating an API as an element and being able to do really neat things with it. So these are all built. We built a whole set of Google Web Components. These are at varying degrees of polish, so I wouldn't dive right in thinking I can use this immediately. The Google Maps one is pretty well mature. But we built a whole bunch of Google APIs as Web Components. We also built a whole bunch of other APIs as Web Components also. So we have a Firebase element that we use in that Topeka app that I showed earlier that does all the communication with the server. And it's amazing. It's kind of a weird thing at first. It was a weird thing for me at first to look at an element as an API. But when you get data binding into the mix and things like that, it's actually a really elegant way to do simple things without a whole bunch of boilerplate code. So you can see now a web component's vision coming together. We should be able to find elements somewhere that someone creates that do the exact thing that we need, that solve the problem that you're trying to solve. You find it, you install it, you import it onto the page where you want to use it, and then you just use it on your page like you would any HTML element. So now instead of the 100 or so elements that you get today, you have literally infinity elements that anyone could create, that you could create, that a community could create, that a company could create. You can find them, you can import them, and you can use them. So to use a metaphor, the old web is kind of like Duplos. You get these building blocks that are kind of big and clunky, but they fit really well together. But if you want it to do anything, expressive or fancy, you might need to attach some string to it, or glue them together, or paint them the right color. And with Polymer and web components, you get a 3D printer. So now you can print anything you want, and it's awesome. Well, I can print any element I want. I can print any Duplo that I want. But again, it's almost too powerful. It doesn't. I'd have to think about all the things that I would need before I start printing. And with the element sets, in addition, now you get a starter kit of all your Duplos and Legos that you might need. With the paper elements, you get a really cool set that's all work together and they're designed in a specific way. And you have Polymer, and you can 3D print your own elements. So, and this isn't just the components that the Polymer team built. There are tons of people building components, and that will hopefully only grow. And so you can imagine a world where you have literally hundreds of thousands of different components with varying degrees of completeness, and you can just find the ones that solve your problem, import them into your page, and use them. So where are we now? I mentioned that Polymer is a relatively new project. It is. It's very young. We are still, as of this moment, in developer preview. So we've been in developer preview since last I/O when we announced this. And really, developer preview is just a nice way of saying experiment. So Polymer evolved along with the web component specs. Web component specs obviously were very volatile at the beginning, so Polymer was very volatile. They informed the development of each other. But web component specs are now hardening pretty nicely. And so Polymer, we've been in this experiment for a while, and we decided to look back and say, give ourselves a report card. Look at the library in a holistic view, take a step back, take a few months really, and evaluate how the library is doing, how the ecosystem is doing. So we gave ourselves a grade. For ergonomics, it's an A. It's great. It's really easy to use. It's really easy to build these elements. It's really easy to compose them together. For productivity, it's an A. It's, you can imagine we built this Topeka app in a week. You can build similarly complex material design apps using the material design elements very, very quickly. For expressiveness, it's an A too. You can express these very complicated APIs as declarative elements. Performance and complexity, it was a pain to give an F, so we said needs improvement. A little loosey-goosey. But it did. It needed improvement. The library was built up as the web component specs evolved, so naturally you're going to get some bloat. And it was very complex. There's a lot that we had to do to make it work that ended up creating a very complex library that was hard to reason about if you were to dig into the code. So we announced a new release that is in progress, 0.8. Currently we're at our 0.5 release. And very shortly we're going to release 0.8. In 0.8 we took a brand new look at the library and we said, what if we took this very expressive library and went feature by feature, just totally optimizing the heck out of every single step. So started at the very bottom, just sugaring document.register element all the way up through data binding, and looked at every single feature that you get and build it all from scratch and retest how fast each layer is. So we know exactly the cost of adding in features, and we don't end up with this bloated library. It's very methodically done. So we did that with 0.8, and the results were great. It's 5 times faster than 0.5 on browsers that natively implement web components, so on Chrome. It's actually even faster than that on browsers that require the polyfill. So on Safari, especially mobile Safari, we've been seeing about 8 times faster, depending on what you're building. But I didn't want to put that on there. I put the conservative 5 times faster. It's also 87% smaller. So this is really important to web developers, obviously. You want something really small. The first library was big. There was a lot to it. The second, the 0.8, is dramatically smaller. The library itself, gzipped, is less than 10K. And then the library, even with the polyfills, so even on browsers that need polyfills for this to function, it's in the low 20K gzipped. So it is very on the low end as far as JavaScript framework or libraries go. Even on the framework side, it's on the low end. Because it's simple. I mean, it's just sugaring over web components, but it's the really expressiveness that gives it its power. So yeah, it's much, much, much smaller. So 0.8 is imminent, a little bit on our roadmap. We are putting the finishing touches on it as we speak. We're going to do a release candidate relatively soon to get the kind of community playing with it and make sure that it's good and the APIs are good. The surface area from 0.5 is relatively the same in terms of the things you can do, very much the same. It's just all reconstructed under the hood, but there are some changes that I think we'll have to feed out there to see how they work. In 0.9, we're looking for that to be our kind of beta release, which we're hoping to release in Q2. Soon after 0.8, there shouldn't be a lot of API changes between those two. And then going for a 1.0 production-ready release sometime mid-year. But that said, a lot of companies and a lot of websites are actually using 0.5 in production. It was stable as far as libraries go. It just was kind of slow on mobile Safari. So we knew that if we wanted this to have a future, we needed to re-architect it. And so we did that, and we made the leap in dev preview. We didn't want to get to a 1.0 and then say, oh, sorry, everything's going to change. Thanks for joining us on the ride. Here, get on this other train. We did that right, very, very early, saying it's still in dev preview. Okay, we're going to make some architectural decisions, hard decisions now, and that's what 0.8 represents. So the great part is Polymer is not alone in this web components world. We're not the only ones doing this. Mozilla is building it. So they've built brick elements out of the Xtags library. Very similar in terms of what it does as Polymer. It's a sugaring over web components. And so they've built a whole bunch of elements as well. So you can use these in Firefox OS. It's used heavily. Brick app bar, brick deck, brick tab bar. Again, similar idea. They're just elements that you can use. They're based on web components. The great thing about web components, though, is these are native APIs that ultimately they're calling. So you can use these brick elements directly with Polymer-based elements and be none the wiser. You don't have to worry about it. You can use a core icon. You can even use a third unknown web components library that's built sometime in the future that may be way better than everything else, and an element with that, and it'll just work. They're just elements at the end of the day. So web components can work together. They can work together with each other. They can work together with frameworks that do more high-level structure and logic. And it's not just browser makers either. There's a community that's emerging, that's building up, that's creating elements themselves, and this is amazing to see. So what if you wanted to encapsulate Twitter Bootstrap as a set of elements? Yeah, it's a very widely used design framework. So there are a whole bunch of examples that do this. One is Twitter Bootstrap Grid, which gives you kind of the grid properties as elements. Similarly, if you want a router, I mentioned routers earlier, App Router does kind of URL routing for you. So it parses a URL path, a hash URL path, and displays the right page that you want. And again, it's all declarative, so it's really easy to read what your router's doing and see what HTML markup is being displayed to your user inside of that. Pager, similarly, pages, if you need pages of results or something like that, and you don't want to have to write a whole bunch of JavaScript boilerplate code to get that to work, Pager was built to give this to you really easily if you want to page through a bunch of results. Ajax form also, if you want to submit forms in the background using Ajax, we can build that as an element. This actually, interestingly, shows the extension, the syntax for extending an existing element. So instead of an Ajax form tag, its form is Ajax form, and then you get all the behavior of Ajax form. It's baked right into the prototype. We've built entire apps with Polymer already. So example of some productionized apps that have been built with Polymer. Obviously the site, we eat our own dog food. We built that out of Polymer. ChromeStatus.com is built out of Polymer. The designer itself is built out of Polymer entirely. It's actually built as a Polymer element. So we've got lots of fun demos where you drag a designer inside a designer and then drag a designer inside of that designer inside of that designer, and it turtles all the way down. And it's totally elegant. You can totally define inside your internal designer exactly what you need. So a designer is built entirely out of Polymer. Santa Tracker, which was wildly popular over the holidays, was built entirely out of Polymer as well. And it was localized, it was internationalized, it shipped across dozens of countries, built out of Polymer elements. And the code for this is actually really elegant. And again, a team of like 2 people built this in a few weeks. It was pretty incredible. And the current I/O website is built out of Polymer. So this was built relatively recently for the upcoming Google I/O, and this showcases a lot of the power that Polymer elements can give you and how simple. Again, this was also built by a group of a couple people in a couple weeks, and it's a really complicated, very modern feeling website or web application. And even non-applications and non-Polymer users are using web components. So GitHub actually uses web components. They don't use Polymer, but you don't have to use Polymer to use web components. So they've created a local time custom element. I believe the name has since changed. But to display all their timestamps, they use a custom element that does all the logic localization for times itself on the client. Great example of just being able to drop it in. They obviously didn't have to rebuild GitHub from scratch. But they can use this custom element, and it solves this set of tricky problems that you don't want to have to really worry about. So join the revolution. Again, as I said, this is brand new. This is based on specs that are evolving as we speak, but relatively stable. But there's still a lot of good input that's coming in. Learn about web components. Webcomponents.org is kind of the shared website that all the organizations that are involved with web component specs and in the libraries and browser vendors, we're all a part of this. We're all contributing to this. The community is contributing to it. It's run by a community member. So it's a great site to learn about what web components are. Polymer project is also a great site to learn about Polymer itself. As I said, 0.8 is landing very, very soon. We do everything in public. It's all open source. Our preview branch is in GitHub already. It's a branch of the Polymer library, so you can check that out. There's a primer. You can kind of read through it. Caveat is all the features, everything that's described is totally up in the air. So we'd love feedback on that if you see something you don't like, and thumbs up if you see something you like, as well as pull requests, of course. And building apps is relatively easy. You can do this today. You can start with seed element. This is a great place if you want to build your own element. So we've created an element that's a template for an element. So this sets up things like testing for you. There's a great tool that one of our engineers wrote that lets you test elements. It creates kind of a DOM that lets you poke and prod at elements for you, so you can test elements in isolation. And if you're a Yeoman user, you can use YoPolymer, and it'll similarly generate all the things that you need to start building your first element and test it and deploy it correctly. And then explore. So it's a wide world of web components out there. We've seen a lot of really neat projects come through just in the last couple of days. It keeps getting neater and neater. Someone built a chessboard that you can set up chessboard out of elements. We've seen all kinds of markdown editors built as elements. And you can imagine that the power that the community would have if we could all create elements, and we could rake elements, and we could rate elements and leave reviews and use them and test them and get all this validation. And then you could support them, and you could have teams building sets of elements that all work together nicely. And you would totally revolutionize the way of doing web development. Nothing like this exists or could exist really on any other platform. And with the power of open source and kind of the power of web components, we could create the total new web, totally redefine HTML. So it's an exciting time. I think that with Polymer and web components and other web components libraries, as well as with the new specs that are coming through the W3C that let websites have all kinds of new capability, like Service Worker giving you push notifications and background caching and things like that, we're really entering a kind of golden age of web development. And so I'm excited to see where it goes. Thanks for listening. All right, so I think I got 7 minutes for questions. So yes?
So how well do polyfills work? Can you always emulate everything? Do you sometimes get a performance penalty for stuff that doesn't work?
Yeah, great question. So in general, the polyfills are very good, and they are evolving quickly, getting even better. The polyfills is where I mentioned Polymer works on IE 10 and up, Safari 7 and up, and then modern evergreen browsers. And the polyfills is where that limitation exists, because some things you just can't polyfill. And I hate to say that Polymer doesn't work on those browsers, because really all it is there's some edge case bugs that you just can't get around. So you're exactly right. You can't polyfill everything. Custom elements and HTML imports and templates are relatively straightforward to polyfill. As you might imagine, HTML imports, you can access XHR things in, and custom elements, browsers don't cough or choke if they see an element they don't understand. So those are relatively easy to polyfill. Shadow DOM, as you might imagine, encapsulation, composition, way harder to polyfill. So actually, at the end of the day, you really can't polyfill CSS encapsulation. You have to kind of shim it and fake it. And the Shadow DOM polyfill is probably the most amazing piece of code I've ever seen in my life. It's incredible what it does, and it was written by some of the people that really helped evolve JavaScript from its beginning. So it's a masterpiece of JavaScript and shows you the flexibility. But you obviously can't polyfill everything. So it works it works well in the browsers I described. There's some edge case issues in older browsers than that. But yeah, so the thing with Shadow DOM polyfill is it was very big, as you might imagine. It has to wrap every single element on the page, and also kind of slow to start up. It has to wrap every single element on the page, because the Shadow DOM polyfill is a pure polyfiller. It tries to be a pure polyfill, so that I can call element.createShadowRoot on any element, and it'll just kind of do that for me. And that's a huge task. So with Polymer, we were building 0.5, and what was keeping the code size especially high and the startup performance especially slow was relying on this entire polyfill that faked the whole world, when really, in reality, 99.9% of Polymer users weren't creating arbitrary shadow roots on their elements. They were just using how Polymer's opinion of how Shadow DOM works in their apps. So they were just using the template being put inside a Shadow DOM and expecting that to work. So when we took a look at 0.8, a lot of these massive performance improvements came from, instead of trying to use the entire pure wrap the world polyfill, we took the pieces that Polymer itself needs and baked them directly into Polymer, created kind of DOM APIs that do what we think they should do in that world of Shadow DOM. And so that's where the dramatic speed up and the dramatic size cut down. A lot of that comes from. So it no longer uses the entire Shadow DOM polyfill. It uses the polyfill light, a very lightweight version of it that wraps the world in the way Polymer thinks it should. And so that lets it be really, really fast. Yeah. Yes.
What was the bottleneck when you were, or like your team was optimizing performance from 0.5 to 0.8?
Yeah, so as I mentioned, the main bottleneck was Shadow DOM polyfill. That was like far and away the biggest bottleneck. So relying on the polyfill to do all the projection and just kind of expecting Shadow DOM APIs to be there. So we re-architected the way we expect Polymer users to proc and prod at their Shadow DOM if they do want to do that. And that was kind of what got us a huge performance improvement. We also rethought about how our data binding system works. So Polymer provides a data binding system if you want to build an app out of Polymer. It's a two-way binding system. It was very magical in 0.5. It used object observe, and everything just kind of worked, and you could bind to one thing here and another thing way over here, and then they'd magically be synchronized. And it was really powerful and expressive, but as you'd imagine with a lot of systems that try to do intense two-way binding, it gets complicated and it gets magical really quickly. So we re-architected the data binding system also from the ground up. We're no longer using object observe to be able to arbitrarily observe things. We're passing messages up and binding down. So it's a one-way, two-way system now that's way more performant and way more explicit. If you want to do so, it still does the simple case really well. So you can still kind of picture it like two-way binding if that's how you're used to. We sugar a lot of the event listening and then changing to get your two-way binding way of doing that. But if you want to use it in a one-way binding way, if you don't want to use it at all, that's much easier too. So that was another piece of performance. We were having to do dirty checks to get two-way binding to work and to get arbitrary binding to work in non-object observed worlds, and no longer have to do dirty checks. It's just way, way faster with that also. Any other questions? Yes.
In your Google Mapping web component example, do you dynamically update the, say, the lat long attributes, and
Mhm.
will it automatically change location?
Yes, yes, it will. So it binds to those lat long attributes internally. So that's again a use case for data binding, where as the outside user, you don't even have to worry about it. But if you change it and you can tell it it's changed, and it'll bind to the properties on the actual element from the attributes, and it'll update the location on the map. Yes, yes. Mhm.
How's performance looked on like Apache Cordova?
Yeah, good example. So Cordova is a really popular way to use this kind of web technology and then ship it as a native app. And so again, it was okay, but relatively slow because of the way that we were rendering and doing all these Shadow DOM polyfills and things on 0.5. But we've seen a lot of apps being shipped with Cordova. 0.8, you'll get all the same speedups, so it'll be way faster and feel much more native also. Yeah, the Cordova team works heavily with Polymer apps, and they're starting to recommend that as a way to build things, especially with the paper elements. So yeah, it's a nice way to do things. We on the Polymer team tend to stay all web all the way, but obviously there are times where you want to package it up and do a native app. Any other questions? Yes.
So, actually tacking on the question about the Google Maps example, so when you had something like the marker inside there,
Mhm.
is that binding in some way to the parent state, or is it just message pass? Is like the parent firing an event the child's listening on? I'm just trying to figure out like how they work together, what the interface is between those two components.
Yeah, yeah, totally. So you can know about your projected elements as a parent element through DOM APIs that get you into your projected elements. So that's kind of how they can communicate. They can message pass. The data binding won't work declaratively, obviously, because I don't know what the child is going to data bind in advance, and all the data binding is set up, on initial render or when it's first laid out. So you couldn't data bind directly to composed elements. What you could do if you wanted is have a third element that kind of is the parent of those two elements, and that can manage the data binding world and manage the data binding to its children. But yeah, it'd be mostly you'd have to do it through message passing or through kind of directly prodding at the element. Yeah, but again, the data binding system is great. It's really expressive, totally optional. It's one of the sugar pieces that the Polymer library added on because it's really nice. And we found when we were building applications, you don't want to have you end up writing a lot of JavaScript to just kind of do basic binding. And so the data binding system is meant for those kind of use cases. We of course like it, and so we use it to structure entire apps. But by no means do you have to do this. You should be able to use whatever frameworks data binding system that you want to be able to manage this. Any other questions?
Oh, I also have another
Mhm.
question. I was building an app once with another team that we use a checkbox as kind of like a filter functionality.
Mhm.
So once you press that checkbox, it will sort of show more
Mhm.
items, and we had like significant sort of animation lagging for that kind of ripple effect. Do you have any idea how we could avoid that? I mean, one dumb way we did was just sort of set a timeout after that animation
Mhm.
ended, but
Mhm. And this is a Polymer, I assume.
yeah,
Yeah. So it's a great question. And so you want to be able to not necessarily synchronously update DOM and synchronously bind things. And so 0.8 should solve a lot of those problems, or at least give you a lot of ways out. Obviously, the web platform can be tricky to get performant things. And so Polymer's goal is let you do the simplest thing possible, and then give you the expressiveness to be able to work around it if you need to. So that's a good example of having to work around it with a set timeout. But what we're giving in 0.8 is ways to kind of debounce property changes like that. We're giving ways to do batched DOM changes so that you don't have to, when you're poking the DOM and you know you want to make a lot of changes to DOM, you don't have to do those synchronously one at a time. You can batch them. So we're giving kind of the outs for you to solve exact kind of problems like that.
So I think that's about all the time we have for this session. Thank you very much,
Perfect.
Taylor. That
Thank
was
you.
wonderful. The next session will start up here at 12:20, so about 7 minutes from now. Super. That was great. Thank you very much.
Thank you. Yeah. It's fun. It's a fun project to talk about it.
Yeah, it is. I can see that actually.
All right. And you said you needed the.
Yeah, if that's okay. You asked the